Welcome to the team. I am absolutely thrilled to have you here. Let's jump right in, shall we? As your senior dev and mentor, I put together this explainer to get you totally up to speed on one of the most fundamental, yet surprisingly misunderstood, data types in our entire codebase. Today, we're moving way beyond basic data types to master JavaScript strings like a true professional. You've probably seen them used for basic text, but mastering their underlying methods and properties, well, that's exactly what separates a beginner from a pro. So, here is your onboarding checklist for today's deep dive. We're going to master the quote dilemma, measure string data, transform text like a pro, build search logic with index of, and finally, avoid those bizarre string comparison traps.
All right, let's kick things off with Section 1, Master the Quote Dilemma and Initializing Safely.
We're going to start with the single most common rookie mistake I see popping up in pull requests. Creating a string seems simple enough, right? You just wrap your text in single or double quotes. But here is the catch. If you drop a double quote inside a double-quoted string, JavaScript instantly thinks the string ended early. It literally just gives up, leaving the rest of your text as a massive syntax error. Now sure, you could just swap your quote types around to fix it, but the true professional approach is escaping characters using a backslash. By dropping a backslash right before a quote inside your text, you're essentially telling the JavaScript engine, hey, this is a character inside the data, do not close the string yet. It keeps your code base perfectly consistent and completely avoids the whole headache.
Moving right along to Section 2, measure your string data using properties. Once your string is safely initialized without triggering any syntax errors, you really need to remember that in JavaScript, strings aren't just dumb blocks of text. They actually act like objects with built-in properties you can measure. The most common property you're going to use on a daily basis in our code is .length. You literally just append .length to your string variable, and remember, this isn't just some random trivia number, it's exactly how you validate user input. If you're building a password field or maybe a username generator, checking that length property is step 1 of your entire validation logic.
To put that into perspective, if we run .length on a source text string, say I am a string with a few extra words thrown in, we get exactly 18 characters back. This brilliantly illustrates how JavaScript translates abstract text into concrete mathematical data that you can actually use to drive the logic of your app. Oh, and that backslash we used for escaping earlier, that doesn't even count towards the length. You just get the pure, raw character count. Which brings us to Section 3. Transform text like a pro using methods.
Now that we can measure strings and validate their size, let's look at how we sanitize and change them. The absolutely crucial point here is that methods are essentially functions built directly into the string object. Let's say a user types their email address in a wildly chaotic mix of uppercase and lowercase letters, and you need to save it cleanly to the database. You're not going to rewrite it manually. You use built-in methods like to uppercase or to lowercase. Passing the word ninja through to uppercase returns ninja in all caps. But listen up, because here is the senior dev secret you need to internalize. These methods are non-destructive. They do not magically change the original variable holding your data. Instead, they perfectly normalize the user input and return a brand new string, leaving your original data source completely untouched.
Let's keep the momentum going with Section 4, Search Logic with Index of for conditional checks.
Next up in your utility belt is searching through data. You are frequently going to need to know if a specific word or character exists somewhere inside a larger block of text. When you search for a word using .index of, JavaScript scans the entire string and returns the starting numerical position of that word. For example, if it finds the word string, it might return a 12, simply because the word starts exactly at the 12th character. But what happens if the word just isn't there at all? Well, if you search for ninja and it's missing, JavaScript doesn't crash. Instead, it hands you a -1. It's basically the engine's way of shrugging and saying, hey, this word is nowhere to be seen.
Now pay close attention, because this is a senior developer tactic we use constantly. By leveraging that -1 in your if statements, you can easily execute conditional logic. You just write if your string .index of ninja strictly equals -1. If that evaluates to true, you know with absolute certainty the phrase is missing. From there, you can trigger an error message, block a form submission, or run whatever fallback code you need. It is literally an absolute goldmine for conditional checks.
Finally, we reach Section 5. Avoid string comparison traps and the quirks of the language.
Okay, we've initialized, we measured, transformed, and searched. Now we have to face the final boss of today's mentorship session, the quirky, bug-inducing reality of JavaScript string comparisons.
You can compare strings with standard operators just like you compare numbers, but you must always remember that JavaScript is strictly case-sensitive. Comparing an uppercase ABC to another uppercase ABC, that's a perfect match, evaluates to true. But if you compare an uppercase ABC to a lowercase ABC, JavaScript immediately returns false. It doesn't care at all that the letters are technically the same alphabet characters. The casing makes them entirely different entities in the eyes of the engine.
Let's see how this builds into our golden rules for comparison. JavaScript compares strings alphabetically, meaning A comes before B. Simple enough, right? But to avoid those junior traps, you have to memorize a truly bizarre fact about this language. Mathematically speaking, a lowercase letter is considered greater than an uppercase letter. If you check if a lowercase a is greater than an uppercase a, JavaScript actually says true. It completely defies standard logic. So what's the professional takeaway here? Always convert your strings to the exact same case, usually by running dot to lowercase on both of them before you ever try to compare them. Normalize first, compare second. I promise you, that habit alone is going to save you hours of debugging.
All right, look at what we've covered. You now know how to safely initialize strings without breaking the code. Measure them with the length property. Transform them non-destructively. Search them using that -1 index trick, and navigate those wild case-sensitive comparison traps. You've built a fantastic foundation today, but I want to leave you with a question to ponder before we meet again for our next explainer. If you have a massive string of data, and you only need, say, the middle 5 characters, how do you precisely slice it apart to extract exactly what your app needs? Think on that, because that is exactly what we are going to conquer next time. Really great work today. I'll see you in the codebase.